안녕하세요. Corey Johnson, 입니다. My interpreter expressly told me not to try this next one, but 위아름 cool하다. So if you don't understand me, then she'll say that I'm trying to say VR is cool. So my name is Corey Johnson. I'm a product manager at Unity Technologies, and what that means is it's my job to talk to our community, all of you, listen to what your needs are, and take that and make sure that you guys have a voice inside our development process. Today I'm going to give a kind of high-level overview of the state of VR in Unity, and I'll have plenty of time for questions for specifics at the end. Specifically, what I'm going to start talking about is what platforms we currently support. We recently added some to this list. I'm going to talk about each of our partners and kind of what they're positioned for in the market and what kind of input devices they have. Then I'm going to talk about our workflow in Unity. How do you go about taking a Unity application and making it a VR or AR app? I'm going to talk a little bit, some tips and tricks that you might need to know as well. Then after that, I'm going to go over our roadmap and talk about what we're going to be working on next. And then I'm going to talk just briefly about labs, which you saw in the keynote. So I'll kind of recover that and talk about what they are, but they're kind of our roadmap of the future. And then we should have plenty of time for Q&A and have a special guest star. So first, why use Unity to do AR, VR? Well, the first reason is everyone in this room. Like, our community is such a large, valuable asset, and VR is so new. It's a great, it's really good to be able to learn together and try new ideas against each other. In the case of VR, it's really good to have a bunch of free testers to make sure you don't make anybody sick before you ship a game. Next, we think we're the #1 engine in VR development, and we're committed to maintaining and strengthening that position. I'm going to talk a little bit about some of the things we're doing to do just that later in the talk. And of course, just like if you're all using here at Unite, you probably know cross-platform is key for us, and we're taking that into our VR work as well. So if you make a VR, AR content, we want to make it as easy as possible to take that content and get it on all the target platforms and devices out there. So up next, I'm going to talk about our partners and highlight some of their differentiations, and hopefully you'll see that no matter what market you're targeting, what users you want to reach, Unity is a great choice to do that. First up is Oculus. Our first partner was the one that kind of kicked off this latest VR frenzy. They just released last week, so congratulations to them. They're actually the first commercial high-end device to hit the market this wave. There are others out there, but the ones that are making the news these days. They require a high-end PC, so they're suited really well for high-end gaming, mid-core gaming, things of that nature. But they're also useful for educational purposes. They shipped with a Xbox One controller and a simple remote device for just clicking and using directional pads and a couple other utility features. It's very easy to set up, so it's good for casual to hardcore gamers. They have announced that they were releasing some motion or hand tracking devices in the future, but because they're at an additional cost and they're shipping later, you won't be able to count that they're there, or count on your users having them. Oculus partnered with Samsung to create the first mobile-based VR headset of this generation. Again, there's others out there, but they're the ones making the news. It's run on a mobile device, so it has slightly lower system specs, so the experiences are generally shorter and like 5 to 20 minutes, things like that. The main input is a touchpad on the side of the device, and you use the gaze direction, that is where the user is looking, so they can select something and then tell you that they actually want to select it. It's a wireless device, which is really strong, so the user can then spin in any direction they want for as much as they want. You don't have to worry about being tangled up, or you don't have to design a way to get them to turn right after they've spun around to the left a bunch. But don't have them do any backflips or anything like that. We recently announced that a partnership with Google to bring official support for Cardboard to Unity will be coming very soon. They still have their really excellent plugin architecture, but we're going to officially make it one of our supported platforms. It's another headset powered by a phone, so it's also good for very short experiences. For input, both devices that they shipped have basically had what equates to the user tapping the screen. And so again, you just use where they're looking at, and any kind of touch to the screen means that they've done input. The good thing about Cardboard is that it's very cheap to produce, so it's well suited for very casual or people who didn't even know they wanted to do VR today. You can hand them one of these things, they can put it together and try VR. It's also good for if you have like a museum experience where you want people to do things, you can hand them out very cheaply. Just last week at Build, Microsoft announced it's actually shipping the first wave of HoloLens devices to users. This is our first official augmented reality hardware partner, and currently we are the easiest way to create content for this device. I'll point out that you can actually go to our website, unity3d.com, and if you look on the main page, there's a HoloLens banner. You can click on that and get all the information you need. You can download the technical preview to use it, and you can actually start building HoloLens apps now, even though you don't have a device, because it works with the emulator. It's another wireless device and battery powered, but it's a little bit bulkier, so it can last quite a bit. It also has the ability to scan its environment around it and learn from it, so you can do really good mixed reality things. That is, if I were to stand here, I could throw a ball and have it actually bounce off the back wall here because it can read and detect that there's a wall there and pass that back to me. It's very good for communications. Imagine a warehouse worker walking through a warehouse, and on the ground you can see directions, and then when he gets to the box he's looking at, he can actually see in 3D the components that are in that box without having to open it. The HTC Vive is the first Steam VR device and another big PC-based head-mounted display that's also shipping very soon. Excuse me. The Vive is the first room-scale device. It has a little bit more setup, but once you do that, you have a wide area that you can use, a 5 by 6.5 meter, 5 by 6.5 foot room that you can walk around. And that's a very compelling, it helps with immersion, and it helps with things that, like, if you want to show off a virtual apartment and want to have a virtual walkthrough, it really helps to be able to walk through. Again, it's suited well for high-end gaming and installation type things where you want to have educational experience where they walk around something or things like that, trainings, etc. PlayStation VR launches later this year and is targeted to mid to high-end gamers, but also it's a really good media device as well. It has the largest potential user base at the moment. There are more PS4s sold than there are high-end graphics cards that can run some of the high-end PC stuff. It's also the most affordable. Even if you don't have a PS4, a PS4 plus the headset is still comparable in price to some of the other high-end devices. The standard input is a DualShock 4 controller, but it has more than that. It has a tracking, and you can also use the PlayStation 3 moves, so it has some hand tracking as well. But again, you're not guaranteed that the user will have those. Sony is also focused highly on social gameplay, which is really cool. So they want to make sure that if someone's doing PlayStation VR, that the TV is also rendering something fun, and you can even have multiple people playing, viewing the TV, and one person asynchronously playing the same game in the headset. So those are our big platforms, and they're the largest, so we think we're everywhere you want to be, but there's so many other platforms out there, like just in Asia, like there's hundreds, and they're all very good. Most of them, if they get popular, will soon provide a Unity plugin, because we're the most supported one out there. And if not, you can use our native plugin interface to easily wrap their SDKs and build your own Unity SDK integration, or sorry, your own Unity integration. So let's talk about the workflow. Sorry that's so small. But the good news here is that building your experience is exactly the same as it has been. If you know how to build a 3D game or app in Unity, you can build a VR app. The one caveat that I'll highlight that you should do is make sure that when you build your VR or your world that you know you want to bring into VR, that you build it to scale. And that is 1 unit in Unity equals 1 meter in real world space. So you just want to make sure that all of your assets are built to that scale, because if you say build everything where 1 meter or 1 unit in Unity equals 10 meters, when you switch on VR, what will happen is everything will be 1/10 the size that you want it. So once you have your project up and running and you have some something to look at and some interactions and you're pretty happy with it, how do you actually support VR? Well, we made it really easy. Inside your player settings, there's one checkbox called Virtual Reality Supported, and you just check that box. That's pretty much all you're going to need to do, but I'll kind of go over some other things too. So the first thing that happens is you'll see that a Virtual Reality SDK's display pops down below, or input. And what this is depending on the platform that you're building for, you can use the little plus button to add any support for any SDKs that we officially partner with. So in this case, I'm building for a PC, so you can see I have Oculus and OpenVR support. Now, let's say I had Oculus and OpenVR device and the HTC Vive, and I wanted to build an app that could run on all of them, and I'm doing development. But I prefer to use my Oculus. What I can do is I can rearrange this list by dragging them around, and the SDK that's on top is going to be the default supported. So when the app starts, it'll try to run on an Oculus runtime. If Oculus isn't configured or isn't plugged in, it will then drop down to the next one, in this case OSVR, and if I have an OSVR device configured, I can just throw that on, so I can support multiple devices very easily. There are 2 other options I left in my screenshot here. The first is graphics jobs at the top, and on the bottom there's a single pass stereo rendering. There's no doubt that you're going to actually want to check those checkboxes, but I'm going to talk more in detail about why in just a little bit, so just trust me, and you'll understand soon. The only other place that you'll see options change is on your main camera, or on all your cameras really. And it gets a few more options. It gets stereo separation, stereo convergence, and target eye. So stereo separation on all of our platforms is overridden by the SDK. So in that case, Oculus or the HTC Vive or Steam VR is telling us based on what user profiles have set up, and they set this for us. But if you're building your own device, you'll want to either provide a way to set that or set this for your users so they have a comfortable experience. And what it is it's the distance between your eyes, and so that way their eyes can focus and they don't get tired, and things don't look wonky. Next is stereo convergence. Again, for all of the head-mounted displays that we currently support, this is automatically overridden and set to infinity. But if you're working with stereo TVs or like 3D TVs or stereo monitors, this is actually the depth from the plane that your eyes will converge. So if you imagine to focus on something, my eyes need to look and they converge to a point. This is a distance beyond the screen of the plane of the screen that that conversion points can happen, and beyond that you won't get any depth effect. Target eye is really useful. You can set it to both eyes, which is default stereo rendering mode. You can set it to left or right, and this is good for if you want to do some kind of gameplay. Imagine you have a lab experience and somebody goes over and looks into a microscope. You can actually only render to one eye and kind of force them to kind of go through that experience of closing one eye and looking with one. You can also set it to none. And what that does is it tells your camera to render to the main screen. So this is like on PlayStation VR, that will be the TV, or on PCs, that'll be the main monitor. So that way people who aren't in the VR experience can see what's happening. So you can have a third camera kind of showing a different view of what's going on if you want. And that's it. 3 checkboxes and some optional convenience stuff, and you're in VR nirvana. We're surfing the web like Keanu here. So what's actually happening? Well, first, the camera that you are used to working with in Unity is actually replaced under the hood with a stereoscopic rig. So it has 2 cameras in there, but you don't have to worry about that. Both those cameras are set up with the correct warping and distortion shaders to make sure it works well with the lenses that you're targeting. And the camera itself, its location is just now a reference point, and the camera movement is actually fed by the HMD, the head-mounted display. So Oculus tells us where to track it, and all that's handled for you right out of the box. Of course, if you ever actually ship the product, you know that a checkbox is probably not just that easy. In the US, we have a saying for when something is almost done, but you still got a little bit more work to do. Ship it. Okay, not really. It's wishful thinking, but we're actually going to do the work to make it a better experience for our users. So what are the things that you still need to worry about? Well, I categorize them in kind of two main things. The first is input and UX. As you saw when I went through all the platforms, the input devices across VR right now are vastly varied. They go everything from one single touch to the screen, to hand tracking, to skeletal hand tracking if you have third-party peripherals, etc., or to do gamepad controllers even. That's pretty simple. Like if you've made a game that works on a PC with a mouse and keyboard and you ported it to a mobile device with a touch input, vice versa, all the techniques that you would use for that kind of situation will help you here. Abstracting the user's intention from what they're actually doing. So instead of having like input is key down spacebar, tell the player to jump, you would just say, okay, well, is the player intent to jump? Well, then do that, and then on a separate page, you would say, depending on my platform, what key or what input actually sends that intent to jump. And so you just want to separate that, and it'll make it easier to port. I'll talk about later about how we're going to try to help fix that in the roadmap talk. The UX experience, though, is actually a little bit trickier because simple concepts like a button is actually really hard to imagine because we don't walk around pressing things in the middle of the air or anything like that. So actual getting user input is something that requires a lot of thought. These days, luckily, like pretty much everybody is talking about it. I'm going to talk a little bit about it, but not too depth because pretty much every conference you go to will have like 7 talks about it. The second thing you need to be concerned with, you should also be really familiar with, and that's performance. As always, more performant applications are better. But in VR, the issues with it, if you have poor performance, can range from, oh, they're just not immersed and they don't like my app, to physically making the person ill. So it's really important that you focus on performance. As I said, VR UX experience is much studied and talked about subject these days. A couple of our partners, and my slides will be available after the conference, so if you can't read those, don't worry about it, you can get the slides. But Oculus and Google both have really good, getting started and best practice guides. Some of my favorite things to point out to people new to VR design are you want to avoid making the user sick, which seems intuitive, but it sometimes can be hard to do. So what does that mean? Always maintain a stable horizon. You can put your user on something like a boat, but you want the horizon to be stable, so they always have some reference point. Always maintain head tracking. If you never override the HMD's input, we allow you to do it for very specific cases, but never do it. You never want to lock anything to the head. So imagine if the user presses pause and you throw up a menu. You still want that menu to stay relative and be part of the world so they can look around behind them and not see the menu anymore. Because if you put it in front of them and it follows them, you'll have some mess to clean up in your VR lab probably. Be mindful of G-forces. So no matter what you show and what the user sees and hears, they're always actually just going to be standing or sitting there with gravity pulling them down. So imagine if you're racing your car and you make a hard right turn, you're going to feel, your body expects to feel a force pulling you to the outside because your momentum wants to keep going forward. So if you do that same experience in VR, the brain is going to expect that force, but it doesn't exist. So if you can build experiences where you can bank those turns, like maybe a car is not a good analogy, but imagine like the road turns, and you can line up the expectation of that turn, because if I was in a plane and I made a hard turn, I would rotate so that force pulling me outward would still be somewhat down, and it will line up better with reality. Humans also can't feel velocity, we can only feel acceleration. So imagine, again, you're taking off in a plane, you get pushed back in your seat, you feel the force, but as soon as we get up to full speed, you feel like you're just sitting there. And again, while they're in VR, unless you've got some kind of cool contraption that I haven't heard about, like they're not going to feel any kind of velocity. So make sure that you skip acceleration. It's better to just have the user start going fast, if you can. Like obviously that breaks some realism, but it can avoid some motion sickness issues. We're pretty good at standing. I bet if I really tried, I could stand up here and talk to you guys all day. My throat might give out, but if I were to hold something all day, I'd eventually get tired and my arms would flop. So imagine like when the Kinect first came out, or the Wii U, and everybody was like playing Wii tennis and just swinging their arms, but like nowadays, you just kind of lay on your couch and kind of move your hand just a little bit. The same thing, like humans have a natural tendency to be lazy. Maybe that's just a US thing, I don't know. But you want to be mindful of what you're making your user do, so you're not having them like run around with their arms up because they're going to be tired and not want to play your game for a while, so just think about it. The human eye can actually get tired. It usually doesn't happen, but every time you look at something close up, you're essentially crossing your eyes. So if you make your user focus on something real close and then look way in the back of the room and then focus real close and look in the back of the room, their eyes can actually get eye strain and tire them out. So you want to keep things that you want them to focus on in a relatively narrow band, usually 2 to 5 meters. This next one's really important. No spiders. I don't like them. VR, the whole goal is to be incredibly immersive. And what that means is, I actually believe I'm in that world. So if you put me on a cliff and I have fear of heights or agoraphobia or claustrophobia, especially if you have like something strapped to your face and on your ears, you can trigger people's real world fears. And so just be mindful. Like I haven't seen people do a very good job saying like, hey, if you use our experience and you're afraid of heights, just know that there's a section in here where that might get triggered. But just be mindful of that. But you can also use these for good. Say I do have a fear of heights. You can put me in a virtual cliff and kind of introduce it to me slowly without actually putting me on a real cliff, and maybe I won't freak out as much. My last point I want to make is just stay creative. VR is so new that there aren't any established paradigms. So in this case is an excellent example from Fantastic Contraption. Their UI, their toolbox where you get things to build in the world, is a pin-headed cat with 2 tails, and you rip pieces off it to build the world. And when you're not doing that, you want to feel good, you can pet it. So just stay creative. Like imagine like late 90s internet. When you went to a web page and there was blinking text and sparkles followed your mouse, and maybe I'm just old, but you had to figure out, where do I log into this website? Well, now you go to a website and you just look to the upper right, and you know that's where the login information is. We all accept that. VR's not there yet, so go ahead and play around, be creative, and try new things. So I just want to make that point. Next, I'm going to talk about performance. So if you came to my graphics talk, these next couple slides might look familiar. So performance is an area where we're working really hard to help for you. So in 5.3, we did a lot of work to do some multi-threading in the engines, like physics was multi-threaded, culling, like navigation. We multi-threaded a lot of the way. But essentially when it came to rendering, we still had a single-threaded situation. That is, one thread's dancing around in the middle and the rest are kind of standing around watching. And the main threads were all your code runs. So we're taking up time that you could be used to make your game do cooler things. And we're dedicated to getting out of your way. So what are the things that we do kind of on the main thread? Well, the main thread does render loops, it sorts the renders, finding out what to draw, setting up lights, materials, etc. And then we have something called the render thread, and that thread is responsible for giving that data and all that setup work over into the graphics APIs like OpenGL and DirectX. So in 5.4, we got really good results in optimization. So the first thing we did was jobified the previously mentioned main thread work. And so as you can see from this profile snapshot, all the worker threads along the bottom are all now busy doing things, working on, doing things for you, and that means that there's more time in the main thread for your code to run. So here's some numbers based on a real-world PC console VR title that's shipping very soon. So they sent us their project, and we benchmarked our findings. So in 5.3, we were getting 10.6 milliseconds on the main thread to do rendering. And in 5.4, and all we did at this point was optimize our code and data layout. And we dropped down to 7.4 milliseconds. So if I was on a game team, or I've been in game teams in the past, like getting 3 milliseconds back was like awesome. Like we'd be like literally throwing a party. So that's pretty good on its own. On the render thread, we dropped another 3 milliseconds from 14.3 down to 11 milliseconds. But then we went a step further. We introduced something we call double wide rendering. And double wide rendering is something you can turn on, and this is the single pass stereo rendering that I pointed to earlier at the bottom of my settings slide, is to turn that on. And what it does is we know that we're going to render like a box. So when we start with that box, instead of rendering that box in the left eye and rendering that box in the right eye, we do all the work that we can to like set up the materials for it. We only need to do that once because it has the same materials in both eyes. And we do everything we need to do, rotate it, everything, up until the last second, and then at the very last second we tell the GPU, hey, render it here and render it here, once for each eye. And so we share a lot of work. We also share a lot of things like culling. Instead of culling with 2 frustrums for both eyes, we create 1 frustrum and do culling once and share it. And same thing with shadows. Instead of figuring out what the shadows look like from both eyes, since your eyes are so close together and shadows are inherently not very accurate, especially in computer graphics, we tend to use like low resolution textures. We just render the shadows for 1 eye and use them in the right eye with a little bit of transformation to kind of make up for it, because we know exactly how far we're looking from, and it's not that far. So that's double wide rendering. So when we turn that on the main thread, we drop down to 4 milliseconds for rendering this game, and then 7.3 on the render thread. So we also, like I said, multi-threaded our rendering. So that was the render loops experimental checkbox at the top of the settings I showed you earlier. And if you turn that on, in this case, you get all the benefits of multi-threading and everything gets moved off the main thread. And in this case, we got down to 1.9 milliseconds, which is a 5x increase from where we started from. On the render thread, we only got just an extra 0.1 millisecond from that. I do want to point out that the render thread here, just to make sure it's perfectly clear, the render thread is a CPU thread that is passing data off to the GPU. It's not freeing up any GPU time for you. We're just trying our best to make sure that you end up GPU bound and not CPU bound. Cool, so that's everything we were doing to help you, but of course there's a lot of things that you can do for performance, and I'm going to talk about some of them now. So the first thing you can do is try to avoid image effects. Image effects goes through every pixel that you render, and if you do VR, it has to do that twice. There is one noticeable exception to that, is anti-aliasing. Because the screens are so close to the face, and because the human head naturally kind of moves around and it's really hard to hold still, the jaggies in rendering, when it's not anti-alias, you know what I'm talking about? It's really jaggy and ugly. They tend to crawl and become a lot more noticeable in VR. So it's really highly suggested that you use start with a forward render, with a 2x MSAA, and then if you have enough performance, maybe even a 4x MSAA. But remember that in VR, a 2x MSAA is the same performance hit roughly as doing a 4x MSAA non-VR. Other things you can do is make sure that the CPU doesn't spike. You don't want any stutters in reality. We don't ever see stutters, so if the game stutters or pauses for even the fraction of a second, the brain's going to pick that up and understand something's wrong. So make sure you optimize out garbage collection spikes, use coroutines to take large blocks of work and spread them out over multiple frames. Turn on features like culling and use LODs to make sure you reduce your draw calls. Make sure you do texture atlasing, and make sure you share materials as much as possible. Use static lighting. Dynamic lighting is really expensive, and so nowadays it's probably usually, unless you have a super high-end PC, you want to use static lightings. Either no shadows in your main character, or use like old school like blob shadows where it kind of looks like there's a shadow but no definition and it's just a texture that follows them around. You can use light probes to make sure that dynamic lighting kind of looks like it's effect. So if my character walks from a dark area to a light area, it still looks like I'm doing those things. Oh, I have a mistake in my slides. I'll fix that later. One thing I want to point out is you be careful. One thing that can break your batching is light maps. So if you're using static lighting like I've just asked you to, and then you have multiple light maps, if two objects are something that would normally be batched because they're sharing the same material and they're sharing the same, material, what can happen is if both of them are on two separate light maps, then they will actually not be able to be batched because they're actually using that light map, and that counts as using different textures in the materials, so it will end up being two different materials. So that's one thing to look for when you optimize. Also reduce skinned meshes. Skinned meshes are inherently very expensive, so anything you do to like use just less of them, and it depends on your game. Make sure you reduce render texture updates. If you can get away with it, like render them only every other frame or every fourth frame, depending on what you're using it for, of course. But again, using a render texture basically means you're rendering an entire view of the game extra. And in VR, we're already using that extra one to do both eyes, so anything you do to add more is costly. One thing you can do is simplify your visuals. Studies have shown that like humans don't really care if I look like I'm in like, a cartoon world. In fact, the closer we get to reality, if it's not 100% perfect, we fall into what we call uncanny valley, and it'll throw me off. So it's actually sometimes better to not go for hyperrealism. So consider flat shading. Use lower poly meshes, especially on mobile. And then you can use higher res textures to compensate. Just make sure that you compress them. In general, just on mobile, because the device is on their face and it's battery powered, if you do things like, let's say we have a chess game where I'm sitting at a table and playing chess, and every frame you're trying to see if I've won yet, well, that's just cranking away on the CPU, and that's going to drain battery faster, and it's going to create more heat, making the user uncomfortable eventually. So what you can do is only check every, seconds, that saves you a ton of time. So you'll use less battery power and you'll generate less heat, and then people can play your game longer. And the key to doing all this stuff is profiling. Make sure you're using the profiler to see where most of your CPU work is being done and optimize those things out, or at least make them less. And then use the frame debugger. That'll really help you figure out how many draw calls you have, what each draw call is doing, and where you can actually combine things, and if there are any mistakes. The next thing I want to suggest is, you can change your performance profile on the fly. So let's say you're in a mobile game and you really want this really cool effect in the boss thing. You don't have to run your game with that high performance specs the whole time. What you can do is you can run at a lower profile. So again, you're not updating your particles. You don't have as many of the particles in effect. And then when the boss comes into the room and it's an epic scene, then you can spend a lot of battery power and CPU time and make sure everything looks great. But then once that scene is done, you can go back down to a reasonable performance level, and your game can still look good. But then in those key moments, it can look even better. And just use those things wisely. Don't think that just because you have one scene in your game that you want it to look that good, that the entire game has to be at that bar. Cool. So let's talk about our roadmap. I talked at the beginning about how one of the things that was difficult was the input and dealing with all these different VR devices. So one of the things we want to do is abstract as much as we can into what we're thinking of as verbs. So no matter what device you have, you're probably going to want to have the user, grab something to be able to manipulate it. So we want to provide an API that lets you just say, hey, is the user trying to grab something? What's it trying to grab? And start manipulating it based on what you want it to do. And then we'll figure out if it's like, oh, on Oculus Touch, it means that their middle finger squeezes in. On Vive, it means they squeeze the side of the controller, and various other devices. And on Leap Motion, it means they actually close their fist around something and move it. We just want to abstract that for you. We also want to take and componentize some of the features. So we want you to be able to just create like an object that is your cursor or your hand analog, and just drop a component on it and say, this is my primary or right-handed input, and this other one's my secondary or left-handed input. And we'll do it just like we do with the camera tracking. We'll just say, oh, okay, you just told us this is your left and right hands. We know you're on a Vive. We can manipulate those and do what you want for you. We've also announced NVIDIA VRWorks and Liquid VR support. So for NVIDIA, that means SLI support, which means if you have more than one GPU in your machine, you can use one for each eye, which will allow you double performance. It also is for multi-res shading, which basically equates to, if you imagine you're in a VR headset, you're mostly looking forward and you're going to move your head to look around. And that means that the only part the user is concentrated on is the center of the screen, but we're still rendering, putting just as much time rendering the pixel in the upper left corner as we are the one in the dead center. So basically what we want to do is, well, not just us, but NVIDIA is doing is basically allowing you to render more pixel and more fidelity in the center of the screen and less on the outside. So you're just spending more of your performance where the user's going to look. As always, we're optimizing and finding any performance gains we can just in rendering. That's like our #1 baseline thing that we do. But we also want to improve the mobile VR workflow. We have a really, really good workflow when you have a device attached to you and you just hit play and you can hold it up your head. But like if you have like a Samsung Gear VR, you still have to basically build and deploy to that device. And I don't have specifics yet, but we're really invested in making sure that that workflow is improved in the future. Speaking of the future, I'm going to talk a little bit about Unity Labs. How many were at the keynote and saw Timothy's demo? Oh, not that many? Okay. So you can think of the Unity Labs as the future. If the roadmap is what we're going to do next, Unity Labs is what we're going to do in 3 years. Their job is to figure out what Unity looks like and just development in general looks like in the 5 to 10 year future. 5 to 10 year future from now. They don't want to just be ahead of the curve. They want to be creating the curve when it comes to interactivity and UX and creation. So VR is the first place they started looking at because it's like kind of like the future now. So it's awesome. And they started looking at our dev workflows and seeing what they could do to improve it. So when it comes to VR, their first goal was to take something that's as fully featured and rich as the Unity editor, with its myriad of options, and provide the same functionality in a simple, intuitive way where the creator is literally part of the world as they create it. They need to balance the ability to be very precise, like when you directly manipulate a value in the editor and like type something in to be like 14.3, with the natural ability to want to pick something up and just kind of stretch it and rotate it in a natural, intuitive way. Especially when it comes to physics, like if you have two boxes that have physics attached to them, you're trying to set them on, you can't just kind of like throw them up there. You need to be able to be precise. So I need to figure that out. So they started really small, just manipulating objects for now. Here's a screenshot with the gizmo on the left, and you can kind of see, you can grab those gizmos and move it along a plane or a line, or you can grab the object itself and manipulate it. But we also have on the right the inspector in a paint panel that kind of floats along with you in the world. But what it turned out is that that's kind of distracting. Like if you're manipulating an object on the right, you have to look off to the left to kind of see what the value is you're playing with to get that precise value. It was really distracting and not intuitive enough because you're not looking at the thing you want to manipulate. So in the end, we're actually not going to go with that design. So we haven't figured out everything, but we're actually still trying to solve that problem. So if you have any suggestions, please feel free to email the labs team at labs@unity3.com because we're really invested in hearing from you. So here's where we are today. You can be in VR in the editor VR window, or you're actually in the headset, but this is what the people watching you can see. You can create objects, you can directly manipulate them in the world using the gizmo, you can walk up and grab them if you want to, but we also have what we call the chessboard. The chessboard allows you to manipulate lots of objects very precisely and very quickly, and then it gets out of your way when you don't need it, which is great. So imagine if you're building like a scary experience, and you're walking down a path and you want the trees to be very imposing and make the player feel like intimidated and small. You really want to be in VR so you get that same feeling your player is going to be. And you might want to walk up to those trees and scale them up and be like, no, this tree needs to be bigger and scarier. But when it comes to making the forest behind those trees that are just on the path your player is going to walk, you don't necessarily want to have to walk to each one of them and manipulate them. So the chessboard's a great way to create a lot of things and just kind of manipulate them, but still kind of see what they look like from where the player is actually going to be. Cool. The labs team is working really hard to deliver this in the future, and they want to get it out soon so they can start collaborating with all of you on what the future is going to look like. So that's everything I have to talk about today. If you have any questions, we have a mic floating around. And I do have a special guest, Timony from our labs team. So if you want to ask any questions about the editor VR, she'll be available to answer questions as well. Anybody have questions? Raise your hand. No?
네, 안녕하세요. 들리시나요? 네. 네. VR 모드 지금 아까 이제 보여주신 것도 있긴 한데 지금 그 화각 같은 거라든지 눈 조절 같은 거, 그런 눈 사이 거리라든지 좀 그런 자유도가 어느 정도까지 지금 계획돼 있고
We don't, for us it's just a value you put in. The average is about, what is it? Yeah, so there's an average, but that's data that pretty much everyone is within 6 centimeters, so you don't necessarily need to worry about that unless you're developing your own hardware. Most things like the Oculus Home will configure for the user that's setting it up, and they'll log in and say, I'm Korean, and they'll have already set it up, and they'll set that for you. But you can set any value you want, so you don't have to worry too much about it, because as long as you give the user a way to adjust it, but you can set the default value to 0.071, which is kind of the most average.
I have a question for Unity Labs. How I feel about VR editor right now is that you can place things while you're inside the virtual world, but I'm wondering about actually like giving those objects lives and like programming into it while in VR space. So I was wondering if the labs are thinking about anything like that or have plans.
Yeah, so we'll have the ability to edit any value using the mouse and keyboard if you want, and you'll have the ability to edit components just like you do in Editor VR. We have an idea around what that UI will look like, but we need to test it more before we can show it off. But yeah, the idea is that you should be able to program as much as possible without taking off your headset. But we do assume that if you're going to be doing very intense programming, you'll probably want to do it on your computer.
Sorry, I think I'm not sure this is an appropriate question, but actually I'm planning to making a kind of VR streaming, like video or real-time communication streaming application. So, is there any kind of like public support things out there? Like, as far as I know, it's like a web office things, like peer-to-peer streaming.
So, are you stereo streaming or just 360? Stereo? We are working, I probably should add it to the roadmap, we are working on video improvements, and that does include better support for 360 VR. When it comes to stereo, like it's best to like look at what you need to do, because you'll probably want to encode everything yourself and stream it like outside. So we don't have any support for just like, hey, here's a URL that's going to give you back, you know, a streaming video, render it here. So there is a little bit of setup that you have to do right now. But that's something that we're actively actually talking with partners about, like John VR at first, and even Oculus, about like what can we do to make that workflow better in the future. So yeah. Please fill out your surveys about the session if you can.
또 다름이 아니라 VR 내에서도 이렇게 오브젝트를 크기를 조정하는데 UI 관련해서는 안에서도 이렇게 할 수 있게 하는지 그거에 대해서 궁금합니다.
So, you mean change the size like of the world? Oh, sorry.
그 VR 내에서 이렇게 오브젝트를 설정하는 건 있는데 UI 관련해서 설정하는 게 있는지 궁금해서 여쭙니다.
You mean in editor VR or just in general? Like, like I said, the Unity considers one unit to be 1 meter. So if you scale the objects in the scene editor, it'll scale in the VR world to whatever value you set those. UI is another area where we know that we can help a little bit with like setting objects and things like, or setting the workflow for you and helping you. But any object in Unity you can just scale and it will be reflected in VR. So maybe I'm not understanding that question. All right, looks like it's it. 감사하세요. Thank you.